Guys, oh my god. I've been working on this for so long. I am finally done with this project. This is hand V2, honestly, at this point. And, you know, like, a lot of failure has gone in. And I just want to currently, right now, formally apologize to anyone who is an engineer. I mean, I want to be an engineer, so, you know, like, this is meant in a joking way, of course. But it is so hard, and this is a very simple project. And I went through, like, 200 iterations of the code. So, yeah, especially software engineers, wow. That's all I can say, wow. Now, obviously, I'm not very, I'm not a very, advanced software engineer, so it was particularly hard for me. But let me give you a rundown of the project now in the final stage. It is a hand. That's it. Yeah, it's just a hand. No, it's a hand where I can show my hand to a camera, and it will copy those moves with these 4 fingers. This thumb, well, the thumb, it will come later. This hand design was huge for me. Before I came to this, I was using this, which is a very good hand design. Don't get me wrong. It was really all me. It's InMoves, just like InMoves open source robot, but particularly the hand part of it. It uses these fingers, and then this rope, or this fishing wire actually is what it is, where you can like pull and push and it'll open and close, and you would attach these to a servo. Servo would turn, it would pull. Servo would turn the other way, it would close. And then you would feed all that wire through these holes and you get it out. I tried. It actually worked pretty well. At that point I was using MG996R servos, which were, well, they're good servos. I mean, they're better servos than these, which are micro servos. But the way it was built, there wasn't really the servos were duct taped to my desk. This was duct taped to my desk. And the reason they had to be duct taped was because of the tension of the string. If the string wasn't tight, the fingers wouldn't turn. And I never really got the tensioning right with the first attempt with this system. And so I kind of took it apart a little bit, tried to fix the tensioning. But basically trying to feed this like super curly, annoying fishing wire through holes in like the servos. Like I was using these servo horns right here, and these are designed well. And like honestly, if I was patient or smart enough to have followed instructions the first time, it was hard. I was doing it again, and I just kind of rage quit, took the whole thing apart. Not my smartest move, because I really think it would have worked if I had followed through. But also, I'm using those servos for a future project, which I'll talk about later. And so I pivoted to this. This is the beta. Let me find the name for you. It's on my computer, which is behind the phone. It's the beta articulated robotic hand dash servo actuated by Evan RLD on printables, free model. Thank you, Evan RLD. This was huge. It saved me so much time, and it works. I'll show you the whole, like what it does later. But yeah, so this project started 7 months ago. I saw a video by Mateo Tech Labs where he built his own one with kind of a similar system. And I was like, oh, that's so cool. So, you know, I went on ChatGPT. I was like, okay, let's start working on the code, because at that time I didn't have the hardware. But I figured I have my computer. Let's start working on the code. Well, tag team from ChatGPT and I, before I discovered that I could use Codex, which is better if you didn't know, at least for coding. And that was a big thing that helped a lot. But ChatGPT and I went through a lot of iterations. ChatGPT was good, but it wasn't able to do everything I did, so I had to learn a little base knowledge of Python so I could make my adjustments myself without having to put it in ChatGPT, ask ChatGPT to do it again and again and again and again, because ChatGPT was not doing it right again and again and again. Then Codex is better. Codex actually, I honestly probably could have just had Codex do it the entire way and not learned a single bit of coding. But, you know, I got skills from it. It uses an Arduino Uno R3. This is a really old board. Oops. This is a really old board I got a very long time ago. It actually has dust on it currently, but it's great. It's been very helpful. This is a PCA 9685 servo driver board. These are 5 servos. This is a power bank. The idea for this project was to keep it under 50 bucks, because all I had was 50 bucks when I started this project. But also at that time, I already had the Arduino and the power bank. So really the price was the filament, the servos, the driver board, the wires. Actually, I had wires. But honestly, if you want to keep it under 50 bucks, you can buy really cheap, like ESP32 boards that will do the same thing. Honestly, the Arduino Uno is not that expensive. And this was well under 50 bucks. Like this is, you can also, and instead of the power bank, you can just use this, which is a cord and it has exposed wires. It's really simple. I think I bought it for like $5 on Amazon because the PCA 9685 can't go off the Arduino pin. It needs external power. But I just had the power bank and that's easier. Although in this case, it may have hurt the thing because I had these 4 servos on the hand instead of the current 4 servos. These guys, they were doing the thing. I turned on the power supply, and maybe I bumped a knob or something like that on the power supply because 12 volts, maybe it's 10, more volts than these things are rated for, came rampaging through. The electrons were nice and powered, if you know what I mean. And so some magic electrical smoke started coming out. I made a YouTube short on that, so maybe you've seen that. So I had to get rid of these 4. So those down the drain. And then I bought some new servos because at that time I had only bought 5. Yeah, 5. Because I figured I would only need 5. And so then came these 3, and then I bought a pack of 8. So these 4, these 3, and then I have 1 spare over there. And these 3 also all broke. So this one, something happened in the gearbox. It just makes that noise now and it doesn't turn. So yeah, that one's down. That one disappeared. This one, I think this one just this one has like no resistance. And it doesn't turn when you power it. And I'm pretty sure all of these came from them being under like a ton of load. Because I built it wrong when I first built it. And then this one's the same, where there's very little resistance and it just doesn't move. And then this one was a tester where I was using, and this one just spins. This is not one of the ones I bought. This is from an old project. I think this is from a Crunch Labs kit, and this one also down. So that's 8 servos down the hatch, or not down the hatch, that means eating, in the trash can. So that's been the main issue along with the code. So the code not working because of God knows what, because there's like so much code and I don't know how to make it work. And because of hardware issues such as putting 12 volts through a bunch of servos, needing to buy new servos, blah, blah, blah. Those have been the failures, but in the end, it's working now. Yeah, it wasn't too bad. I highly recommend people to make it. I'll provide the code in my GitHub. It'll be my first ever thing in GitHub. I'll put the link in the description. I'll also put the printables CAD in the description. Of course, everything is free. And then, yeah, I'll pass it over to a quick demo. All right, here we go. So the computer's behind you. That's what's tracking. Let me turn it on. Got it all ready. I'll do it with this hand. That way you can see better. So yeah, so this has taken so long. Let me see if I can get just this finger out. Yes. Oh no, I tried. It's taken so long, so many iterations of code. Oh, the thumb doesn't do it. What am I doing? This type of thing could be used, like, I don't know, say you have like a job they have to do and you can't send humans, but you want to be able to use like the usefulness of a hand. There's a reason evolution came up with one. you can use something like this. It can be remotely operated. I mean, you need to send a computer with it, but you can just like send a video and it'll copy. I don't know what else to show you guys with the demo here, but yeah, that's how it works. Oh, sorry. It's pretty simple. You know, there are varying lengths that it goes up, but they all work. And you can fine tune that. I will post the CAD on GitHub once I make a GitHub. No, that will happen soon. And then for last thing I'm gonna do before I end this video, because I am gonna keep it nice and short, is I have a new project that I've been working on simultaneously with this one. Mainly just 3D printing all the parts because it is much bigger, at least 3D printing wise. Hopefully it won't take as long. And that is a robot dog. I am working on one very similar to Harrison Milburn's Coda. You should totally check out that video. I'm gonna be doing something very similar. I'm even using his CAD and code. Well, I've used his CAD and code and I've modified it a little bit for my purposes. And then, you know, I'll keep working on the dog. Maybe after I build it and just the mechanical body, maybe adding AI, camera vision, like more useful than it just being a really, 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 really cool engineering project. But anyways, this is the hand. This has been a big part of my engineering journey over these past couple months, over my freshman year in high school, which has now officially come to an end. So yeah, that's that. Please subscribe if you want to see more, and then like the video and turn on notifications if you want to like really ensure that you see more. Thank you so much. Bye.